Hi, my name's Rob and this is my second tech talk on automating ArcGIS Pro. Here we see in this Arc toolbox we've got a custom geoprocessing tool called Extract by Spatial Relationship. Okay, and this is a geoprocessing tool which builds on the stuff I talked about in the first session. If we have a look at it, it allows you to add a couple of, well, one or many comparison layers. Compare them to a linear query layer, such as this root line. You can perform a selection on the query layer first, or choose not to only focus or filter on certain features. You can add a search distance, so searching the distance, a given distance for the compare layers to the query layer. You can choose to clip or not clip the outcut, and you can choose to use a group by column to produce some statistics. So this script tool allows you to vary some common analysis that you would often have to repeat. If I just zoom to the output here, so we see we have clipped that root line according to a 100-meter buffer there, and we've asked it not to bother with any tunneled sections such as these, or we can get rid of this. We can change this. And then we can say we're not interested in any statistics, and we don't want to clip. Run it again. And it basically just selects the features that we want. It just gives us any features within 200 meters and extracts them into a new feature class. Okay, so there's one more complicated usage, one more simplistic usage. But this tool, obviously, you could vary it in so many ways. You can add different data sets here. You could add a different route line. We could focus on the other bit of the route we got here. Rerun this analysis. It's quite versatile. Prevents us having to keep manually repeating repetitive tasks. Okay, and this tool, well, it's built, as we can see, it obviously adds the outputs to the map, which is nice and useful for us. But this tool is built on basically it's an evolution of the original logic from the original tool, which was this demo123.py from session 1. Original, I mean from the first session where I was talking about this. And I've just copied and saved that as a new Python file. I've called it Extract Features by Spatial Relationship, okay? Because that's what I want to call this script tool. But first, let's pretend actually working in the professional world actually got a job. And let's discuss our tool requirements. So we want a script tool which gathers statistics on the proximity of features to a proposed route. Good real-world example. The analysis is likely to need repeating for different departments. Yeah, and customers do like to move the goalposts a lot. So you might want to be able to, something a bit versatile, so you can tweak the analysis. You want to be able to compare the proximity of several layers to one master layer. Okay, the tool should have the option to clip the layers to a given distance and provide counts of features, and if it clips, to provide some aggregate area totals. Okay, so you might want the area totals within a certain distance to the route. And the tool should have a validation script. And the tool should be professionally written with code comments, type hinting, internal error handling, and expose outputs as parameters. Now, the validation script starred here and exposing the outputs as parameters. There might not be time to do them in this second session. That might come into the third session. In the third session, I'll go into polishing off the tool, finalizing it, and also some a bit more advanced stuff such as object-oriented programming. Okay. So for this session, the first session was introductory, very basic. This session is not so much the evolution of humans, but it's the evolution of Arcpy from a very basic flat script and into a bit more of a professional geoprocessing tool. So what were the issues with the script from session 1? Well, There were no input parameters, hard coding of parameters. There was no error handling. There's no try except blocks to manage any issues and report these back to the user. So if anything goes wrong, it's not a great. It makes the user experience even worse because you can't tell what's gone wrong. So good. And then obviously there's no flow control. There's no if, no loops. You know, it's all very simple, flat format, one line after the other, copied and pasted out of copy Python command, as it was in that first session. There's no validation of inputs, either up front or at runtime. There's no validation of outputs. For instance, checking the output doesn't exist or the output workspace to put an output exists. That's a common one. And did not even expose the output parameters. There's no GP messages in Pro, just using print statements. So if you want, info, warning, error message to appear on the script tool in Pro, you need to use Arcpy methods. You can't just use print in Python. There's no script tool or metadata or help. Very lazy, not documented it at all. And yes, briefly at the end of the last session looked at an AI-generated answer to the same question covered in that session. It didn't care about all these professional bits to add on top of a geoprocessing tool either. It was just a flat script with no flow control. However, if you're writing custom geoprocessing tools, you really want to avoid this. You really don't want to just have a flat script. You say, oh, it's worked for me, clock off. Nah, you really want to be thinking about writing your own reusable scripts with decent structures, error handling, yeah, code commenting, obviously, flow control, exposing the parameters as outputs, and validation. Anyway, let's try and evolve this script then. And the first thing to do is I'm going to add an arcpy.getParameter statement in here to trap the parameters passed in for the tool. So what I've done here is I've said query layer equals arcpy.getParameter 0, and I've said compare layers equals getParameter 1. Okay. Now, I think the orderings might be slightly, because this was tweaked later on in the preparation for this recording, but basically if you're saying arcpy.getParameter, it's easier if we actually have a look at it on the properties here, if it goes on the correct screen for me. So getParameter 0 is basically here. You can see them, getParameter 1, getParameter 2, 0 based index. Okay, so that's what arcpy.getParameter is all about. It's about getting the parameters in code. It's worth noting, of course, as said in the first session, Arcpy has a function call representing each system geoprocessing tool as a method. So you've got arcpy.management.makeFeatureLayer or .copyFeatures or whatever. Well, Arcpy has its own internal methods directly on the Arcpy module, such as getParameter. Arcpy.describe is another one. Okay, so it doesn't just have the function calls on it in Arcpy to execute the geoprocessing tools in script, like here, arcpy.management.selectLayer by attribute. You've also got lots of stuff directly on Arcpy to help you when you're writing your own custom scripts, okay? And one such method is getParameter. There's also getParameter as text. Behaves in a pretty similar way, and you can probably guess how it is different to getParameter. getParameter as text converts the value to text. So that's the first bit, is actually trapping the parameters and not having hard coding. I've kept some hard coding here for debugging, but obviously the key thing is getParameter is the way to actually trap the parameters passed in. The next bit, I'm going to take all the code from earlier on, the code from the first session. I'm going to comment that out, and I move these parameters to the bottom, okay? Because how we're going to write this tool professionally is it's going to have an entry point at the bottom of the script, okay? The next thing, we're going to add some error handling and wrap it in a try except block. So I want import sys, not syslog, I want import sys. Sys is a module with system information, pretty fundamental Python module. I'm going to add just a try except block around this commented code here just to start with, and you can see I'm using a sys.exit and passing in this Python exception object down here. Now basically this line of code will be hit if there's like a serious problem, if something's desperately gone wrong. Okay, so that's like the outer try except block, and what this basically says is exit the program. And that's what the reason why that's what's gone wrong. So an exception object in Python, it's Python's way of communicating errors at runtime. When a Python program encounters an error, it raises an exception object, and this is passed back up from calling method to calling method. It's like the call stack, and if an exception is not handled, then the program terminates. If this happens in a geoprocessing tool, this is where you will see the dreaded red text in ArcGIS Pro in the geoprocessing pane. So for now, I'm just going to add a pass statement in there, so this try block's got something in it, so I'm not getting a compiler error there. And actually building on this structure, I'm adding some nested try except blocks as well. Okay, so as well as just an outer try except block to catch a single error that goes wrong anywhere in the script, I'm going to group little bits of the logic within the script, and I want to tell it specifically if something went wrong within that part of the script, and I want it to behave differently depending on where the error occurred. Okay, so we can see here I've got a region, and a region is something I would encourage you to use in Python as recognized by Visual Studio Code. Here it allows you to collapse this section of the script. Okay, we've got our region of primary validation. I'm going to use this try except block here to check the parameters that are passed in. Okay, and then let's just move over where I want my old rubbish code put here. I think from this first session, let's just put that down there. Yeah. Okay. Cool. So, as I say, we've got our outer try block, then we've got a nested try block here, and then another one for the primary validation. I've said another one here. I want a region for secondary validation. So, this is how I work. It's not necessarily how you might want to work, but the point is that you want to be catching errors and reporting what's gone wrong to any end users. Okay, helps you diagnose with diagnostics and having tools which don't have bugs in them, basically. So the first try catch block here, this is for stuff like primary validation. Is for stuff like if somebody has passed in a parameter, it's supposed to be a feature class and it's a table, so there's no geometry column. Big problem that. Yeah, completely wrong. Completely invalid input. Say they've passed in an integer number, you're expecting a value between 1 and 100, and the value is minus 1000. Okay, blow up. Say no, that's incorrect input, and don't carry on. Okay, you always want to be helping Arcpy and validating parameters before they get to Arcpy. Yeah, Arcpy has its own internal error handling, so if we get all the way down to select layer by location, we're passing the parameter just in as the user set it, that's okay, but it's always best, I think, to check the parameters yourself and have your own error handling on top to sanitize stuff before it gets to Arcpy. And then, this is how I work, is I have a secondary validation block, so the primary validation, which we'll cover later on and populate it later, that's stuff like massive errors, like completely silly input. Then we get down here and it's a bit more niche. Say for instance there's like a spatial querying operation and it's passed in two feature classes but they're not in the same coordinate system. For instance, one of them's in the British grid, one of them's in the Irish grid. Yeah, it's asking for trouble. So you can produce warnings in here and say, yes, Arcpy will run this, but yeah, your input's not quite right there. What else we got here? You can trap different types of errors. So this one here is trapping an arcpy.execute error. So if I said raise arcpy.execute error, it will trap this in here, whereas if I say raise exception, it won't jump in. Above here, it won't jump into this bit, okay? So you can tell it to trap different types of errors and behave differently, okay, but depending on the type of error. And then down here, so any arcpy execute error will jump in here. Any other type of error, any other type of exception will jump in here. And on here, I've just said raise. So if anything's gone wrong here, it will raise it, and that will mean it will jump up a level in the call stack. Because there's no except here, it's just a finally, it will jump to here. Okay. And then here we've got an else. So you've got try, except, else. Again, you don't have to do this. You could do try, do your validation here, and then just beneath this, do your clever bit where all your processing takes place, and then jump down to accept blocks. I prefer to work with a try, except, and an else. Okay, so we know down here if it goes accept else, then there's no warnings or problems, and we can continue with processing. And this is where the clever bit would go. Obviously, we've only got old rubbish code commented here, but this is basically where the engine of the script would go. But this structure, so much better, isn't it? I mean, God, scripts like this, terrible. You really want to be, using try blocks all the time. Absolutely fundamental. What else could be improved? Okay, so I've just had a print statement here from my own custom print method. I'll come on to that in a bit. We can see that Visual Studio Code has put a yellow highlight on that saying, what's that then? Don't know what you're talking about. What is GP print? We'll gloss over that for now. And we'll talk about our entry point into the script. Okay, so I've moved the logic above the parameters, and what we're going to do here is we're going to only make this script execute if it is the main, if it is like the main program for execution. So basically it is the script at the top level. Okay, now this is something historically I didn't do so much traditionally, but it's something recommended by Esri. I do it these ways, and it prevents unwanted execution of the script. If you want to know more about it, then Google it. But basically this method here, it checks name equals main. So it determines if the script is being ran for processing, being deliberately executed as opposed to being imported. So def is main. We've got a function call here, and it returns a Boolean. And also I've got my region for local methods here, nice and organized. And then I'm adding an entry point into my script here. So I'm going to wrap this entire outer try except block that I've just added as a method in its own right, okay? And I use tab, shift and tab, select it all. Sorry, select it all and tab to indent, shift and tab, unindents in Visual Studio Code. And I've basically wrapped the entire script execution in this exec method, and you'll notice that I'm adding my Arcpy parameters, passing them into it as well. It's returning none for now. I'll come on to that in maybe not soon, but a bit later on. So there we are. I'm adding an actual entry point to execute into the script, because it's good practice to not have everything execute come what may, whether the script is imported or it's actually ran. Okay, so everything on the far left that's not indented with Python, because obviously flow control in Python, there's no curly braces, it's just based on indentation. So anything over on the far left is going to execute, whenever the script is imported or it's run. So it's going to print the install info there. Obviously, any functions, it'll gloss over them because it says, well, that's a nice little function you put in there, but I'm not going to just run it unless I'm told to. And then we get down here, and I'm going to put the logic to actually, and just comment out that GP print for now, and just so the logic to actually execute the script here is calling that exec method up there, but it's only going to execute if it is main. Okay, so let's run this and see what it does. So what it'll do here, it'll say, okay, if is main, print is main. So it's printed out the ArcGIS Arcpy version at the top there, as per that original print statement. It says is main, but then it's got down here and it's got down to might be main, don't know, because that executes on both code paths, okay, on the far left. So how do you demonstrate what all this actually means? If we have a script which imports, I've got this import test.py in the same folder, and I'm saying import extract features by spatial relationship. It recognizes that by file name. It won't print is main this time. It just says might be main, don't know, and then it says is main is false. Okay, it's saying it's false. So that's the difference. That's something I didn't used to do years and years ago. It is recommended now, and it is good practice because you don't want bits of your scripts executing when somebody just imports it, do you really? The next stage is to wrap this evolving geoprocessing tool, this evolving script, as a geoprocessing tool in ArcGIS Pro. So let's add a new script to this Arc toolbox and call it extract by spatial relationship demo. Oops, doesn't like spaces, obviously. I'm going to use camel case, literally at the start. It's just going to call it friendly name of the label. Description, just leave it as to do. Summary, leave it as to do. Parameters. Banged on about this a lot in the first session. So what we want to add in is the compare layers and query layer in this first version of the tool. And I think actually I'm going to flip the logic before I flip the order, sorry, before I add them in. Yeah, I think they logically work better in this order, with the comparison layers first and then the one that you're querying them against second. So let's add these in. Whoops. So we want the parameter compare layers and then query layer, and let's make them, give them friendly labels, nice user-friendly labels. And this is where that sort of, this framework for geoprocessing tool parameters comes in. So we're going to say, if my parameter data type goes on the right screen, I'm going to say I want feature layer or feature class. You can have more than one type. So feature layer or feature class, and I want multiple values for compare layers. It's required, so the user has to provide at least one of them. Okay, and then for the query layer, we're going to say that one is going to be, again, it's a feature layer or it's a feature class. Yes, it can be a layer wrapped up feature class already in memory, or just a path to a feature class, what those two represent. And this is not multiple values, there's only one. It's singular. Okay. The next bit, if we take a look at, so we got they're both required input parameters, and then you can do stuff like filtering and setting dependencies. A bit more on that later. For the execution, let's just use copy path from Visual Studio Code. Plonk. Let's make it browse to it. In there. Okay, and then it pulls through our script. And then you've got stuff like the tool validator. I'd like to have covered this in this session, but there probably won't be time, but I've talked about this a lot. This is a really useful thing that I've already discussed what it is. Really useful, and I'll definitely cover it before the end of all of these demos. And then environments. Don't have to worry about this too much. It can complicate things, especially when you're just writing your own custom geoprocessing tools. There's something called the Arcpy.env manager. I would encourage you to have a look at that if you want to know more about this. And one environment that I often think is very important that I'm using is maintain attachments, that environment variable. But for now, at this stage, we haven't got to worry about environments too much. When you're more familiar with geoprocessing tools, there's something that you can look at investigating and configuring. Okay, so got our two parameters there. Basically, feature layer, feature class, multi-value, and single feature layer, feature class. And then click OK. And there we got our extract by spatial relationship demo. So then if we open this, we've got our compare layer. So would you put the query layer in, and then we use this. And then let's see what it does. And it will do nothing because we haven't got anything in our actual logic within the actual engine of our script is empty. But you'll notice that print. In fact, if I actually save the script, it'll make it have an effect. But we've got this print statement here. It doesn't actually show. So what we need to do is, instead of print, we need to use something called arcpy.gp.addMessage. And that is how you make the messages appear in the front end. So let's run it again. Now I've added those messages. Okay, and it says, now I've added the messages. It's actually using arcpy.gp.addMessage. It's making them appear. So arcpy.gp.addMessage. The messages actually appear in ArcGIS Pro then. And what I like to use, rather than using print here or there, or using arcpy.gp.addMessage here or there, I like to have like a global print statement. So we can see that this one I prepared earlier, we got this GP print statement, and I'll uncomment my GP print statement there now that I've got it. Okay, and basically it's asking for, I need an extra import module here. I need to import date time too. Okay, so import this, import date time, and there, what we got here is basically, rather than call print, rather than call an Arcpy add message, it's all wrapped up into one method, and it handles the message severity. So for instance, if you want an error message or a warning message to show in ArcGIS Pro when your tool runs, we've got our helper method for printing here as well. So if we go back down here, we see we replace these with GP print. Okay, whoops, I don't want AGP, I just want GP print, and then this one here as well. Yeah, and now I'm going to stick a 1 on that one for the level, which means warning. 0 equals info, 1 equals warning, 2 equals error. Those are the Arcpy error severity levels. Okay, and let's save this. And then run it again. Okay, so there we see that we're getting a timestamp, always really useful. So no matter what happens, we're going to get a timestamp in our output, and the warnings it'll not only show as a warning in the debug console in here when you're testing it in Visual Studio Code, but you will get it actually acknowledged as a warning in ArcGIS Pro. So that's covered geoprocessing messages. The next bit is to delve a little bit deeper on get parameter as text. Looking at parameter behavior then. So, and I did go on about this a lot in the first session, but it is important that you want to make sure that the parameters that your tool consumes, you know what types they are, so that you can consume them properly without any unforeseen errors happening. So first, one thing I'm going to do is I'm going to just get rid of these print statements here. We don't need those from before, and I'm going to comment out these parameter overrides for running the tool in the IDE. Obviously, these didn't matter before because there's nothing actually in the actual execution part of the tool up here, but now we're going to be running it from Pro. We want to comment out the parameter overrides in the IDE. And let's add some actual work into the tool here in the else block where it performs the processing. And so what we're going to do is we're going to select layer by location, passing directly in the compare layers. Select layer by location will take a multi-value parameter. This is a list of layers of feature classes that intersect the query layer. Okay, and then it's going to get the result. The second output for select layer by location is the counts of features selected, and it's just going to print that out to the console. Okay, so I'm going to save that. And then go back to Pro. And I'm going to drag in, I've got a local copy of these areas of outstanding natural beauty. I'll use that as the compare layer. And then for the query layer, I'll use this root line. Okay, and then, so I've copied in, I've dragged and dropped 2 layer objects from my map, and let's run this. And it says 1 feature selected. Print feature counts, features selected. So I've got 1 feature selected, and I've passed the layer object in using the pull down from the map, but look, there is no selection on it. So that's a quirk of how ArcGIS Pro behaves with these parameters. I find it slightly counterintuitive. You can pass in the actual layer object, and yet it doesn't actually perform the selection on it. So it's obviously, behind the scenes, it's obviously rewrapping that layer, but it doesn't show the selection. It doesn't actually select it in ArcGIS Pro. So it's obviously rewrapping it behind the scenes. It's not actually performing the selection on the layer you've passed in. Just a behavior to make you aware of. What should we do next? Investigate further. And okay, so for what this code snippet is doing here, it's getting the active map in the project, and it's changing the compare layers array. Instead of what's passed in, it's grabbing a layer object from map.listLayers, and if it's got the same name, it's passing that in instead. So previously, I pick a layer, AONB copy features, passes that into the tool, doesn't select it, even though it says 1 feature selected behind the scenes. This time, I'm passing in this AONB copy features, and then it's going away and it's looking in this map and it's, that name matches, and then it's performing the selection on that. Let's see if that changes the tool's behavior. So there, we've got 1 feature selected again, and look, this lights up now. Use selected records. And there, a somewhat better place to look. AONB copy features now has 1 feature selected. So, in actually grabbing the layer, even though we passed the same layer in, it doesn't select it. But if you find it again in the map, it does select it. Let's clear that selection down. This depends on how you want your tool to behave. If you want your tool to select things, you know, in you know, so the user can see what's happening, like it's sort of being, you know, it's the tool is actively working as you watch it. You want it to be, you know, automating the front end. You want to see the selections happen as they occur. That you obviously want that type of behavior we just done in the second example there. Me personally, I'm happy with it just doing stuff behind the scenes. As long as the data's right, I don't need to see that selection up front. Let's look a little bit more, though, about passing these parameters in and the sort of and typing of them. So alter this statement here for now. It's getting the compare layers, and I'm asking it to print the type of each, and also just a statement to say if it's a feature layer, okay, using hasAtta. Using hasAtta and looking for the method is feature layer on the object, okay. So, and let's, I'm going to get some different types of inputs, because obviously you need to consider different types of inputs you might want to push into the tool. So this one's a feature layer from a map. This one's a path to a shape file. And for the third one, I'm going to pass a path to the exact same data as this root line, but sort of local data for that. Okay, and then let's just check I've saved the actual script, because if you don't save it, then you won't see your changes as you run the tool in Pro. And let's run this again. Okay, and so this time, the first one, it's a layer object. It's grabbed it from the map. And then the second one, it's a type of geoprocessing value object, okay? So it is automatically converting paths to shapefiles, paths to feature classes as these geoprocessing value objects. If you want to know more about that, consult it in the tool help, okay? So with Arcpy get parameter, and you pass in a string to a data set, what you actually get in your script is a geoprocessing value object. Let's tweak this a bit more. Instead of printing out the type, just want it to print out the string representation of what the value is. So let's go again. And as you can see, the actual layer object, even though it's get parameter, that passes to the layer name, and obviously the path is just converted to string as the path. Yeah. However, watch out for the next bit. I'm going to tweak this to get parameter as text, and then I'm just going to change those two print statements there to be a bit more simplistic. Save that. So we're going to use arcpy.getParameter as text instead. Exact same inputs. Let's see. In fact, let's just double check. I'm grabbing a layer from the map there. Let's see how it behaves. So these are all being passed in and gathered with arcpy.getParameter as text this time. And we can see that it's printed out, getting that first parameter as text. We see it uses a semicolon to separate both of the values passed in. So it's semicolon separated. And you'll also note, with two inputs passed in to select layer by location, the output produced, GP print feature selected, it also, there's two in and there's two out. So there's one feature selected from this, and then naught features selected from this, and it's semicolon separated, okay? So where you have string values pushed in, pushed out from these tools, and they're multi-value, they're separated by a semicolon, okay? But also note the other thing, which is properly counterintuitive for me, is that it's actually done the selection. Even though I've said get parameter as text, and I'm just passing in a text value of AOMB underscore copy features, it's actually selected on the layer. Whereas when I used get parameter, it doesn't do that. So it's just some of the quirks of Arcpy, some of the things to be aware of, really. The differences between get parameter as text, and how Arcpy behaves. I think at the end of the first session I recorded, and we talked about AI generated code. In this AI generated code, it just used strings to identify layers. And I think that's a similar behavior to this, where you're just passing in a string and it identifies a layer it's got open by the layer name, by the layer alias here. But for me, it's counterintuitive. It's the wrong way round. You're saying trap that value as a piece of text, and it goes and grabs the layer by name and actually does the selection, whereas you pass in the actual layer object and it doesn't. But anyway, just a quirk to make you aware of there. Moving on. We want the tool to be versatile though, okay? And if you're passing a layer object in, you want these parameters to handle both feature class, path to a data set, and feature layer, an existing object, and you might want to access information about that object, okay? So just passing it in as a string isn't the best way to do that. You want to pass the actual object in. So we use arcpy.getParameter, and then in this loop here, we're looping through all the layers that have been passed in, all the values passed in, whatever they may be. This statement here checks to see if the type of layer is an arcpy.mp.layer. Notice we're actually accessing an internal member, a private member. I said in the first video, you don't really want to be going near stuff which starts with an underscore in somebody else's code, because that's internal or private, but in rare circumstances, it's okay. And in this case, to check that it actually is a layer. So this checks if the value passed in is already a layer object, and if it is, your script behaves differently here, and it actually accesses types and members that it would expect on a layer object, such as get selection set. Otherwise, it says that's not a layer. You have to turn it into a layer. So let's run this and see how this behaves. Remembering we're going back to get parameter now. So I wouldn't expect any selection. And there we go. It's saying for anything that's a path, it's not a layer object. You must make it one if you want consistency in your script. And then for this one, it's recognizing it as a layer object and producing the count. And let's actually just select a feature or two on that and run that again. Oopsie daisy, I've got use selected records ticked off there. That's why that's not working. Let's try that again. More on this in a few minutes. But as we can see, the selection set there, we've got 12 and 14. Yeah, so we pass the layer in, but you can also access stuff on the layer. And if we have a look at the attribute table, this will explain the set a bit better. So if we just look at selected records and look, the object IDs 12 and 14 there on this selection set. A set in Python is a collection of unique values. It's like a list you can iterate through, but unlike a list, you cannot assign items to it. So you can't say my set square bracket 0 index 0 equals 1. You can't assign items in the set, but you can add and remove them. The set object has methods for this. And the thing about a set is every single value in it is guaranteed to be unique, which is why it's useful for representing a selection on object ID, a unique index, a primary key column, okay? With this tool, because of, as I've said, these parameters, they accept feature layer or feature class. You want your tool to be versatile, and you want the user to be able to use the layer pull downs, but also add paths. In this case, getting params as objects and not string or text is probably the best approach. It would avoid errors, despite the slight oddity there that I described. So in this script tool, I think the best approach, is to use get parameter and not get parameter as text. And the next bit is I'm going to add a little bit of basic validation. Yeah, for handling this for handling these parameters when they get passed into the script. So as I say, it's always a good idea to sanitize and make consistent any inputs you pass into before they get all the way down to Arcpy. So I'm just going to add a couple of import statements here at the top of the file, come in useful later, and also a couple of helper methods that come in useful later. Okay, and then my type hinting here, I'm going to change compare layers to a list. Yeah, so that should be a list passed in. And as stated before, it can be a list of feature layers or feature classes. And what we want to do is sanitize them before they get to Arcpy to all be layer object types. So I've added a couple of globals here. I've got a C layers list, an empty list, and an X cleanups list, an empty list. And then in the validation, using a range counter here to loop through the compare layers passed in. Okay. And it's checking if the type is an Arcpy MP layer, and if it is, it just adds it to the array. It just appends it into that list of C layers. If it's not, then it wraps it with make feature layer and then appends it in, and it also adds it to a cleanups array. Now, come on back onto the cleanups a fair bit later, but that's basically if you create any layer objects in your script, it's good practice to clean them up when your script has finished all its processing, so you're not leaving locks on data sets, okay? But I won't say any more about that for now. So what this basically means is when this is finished, this C layers list will contain all feature layer types for every data set which is passed in, so that's nice and consistent. It's just sanitizing the input there. It's a good practice, and then if we look down here, I've changed the select layer by location call to use that C layers list instead of pushing compare layers straight in. So I'm using my sanitized input instead to pass that into Arcpy, and then I just commented out this region here. Let's minimize that region, all the old code from session 1. Right, so this file is saved as is. So go back to ArcGIS Pro and let's talk about these selection toggles and how these geoprocessing tools handle selection. So we know we've still got hard-coded 100 meters of the query layer. We want it to perform a selection. We know behind the scenes we're asking it to perform a selection on basically duplicates of the same thing, these two layers. These two layers here are duplicates of the same thing. One has just this feature selected, the other one has these two features selected. Let's see how that behaves. Got some extra diagnostics I added in there, so yeah. Okay, so what this is printing out initially is the counts of what's being passed in. Okay, so for layer in compare layer passed in, print out the count, and then perform select by location and print out the count again. So we'd expect, because we're asking ArcGIS Pro to only select from, it's going to basically ignore everything else other than these selected features. I don't know if that's within 100 meters of the line, but I would expect the output counts to be 0, not 1 and 1. But it seems to me that I've asked it to, on a selection here, use only the selected records, but strikes me it's just selecting this one polygon here, the one that actually touches. So it's completely ignoring that. Why is it doing that? Well, one of the first reasons is a mistake in the script. We've got new selection here, and that basically means that it's, if you want it to take into account features already selected on a layer that you've passed in, but you say new selection, you're telling it to just make a new selection. And consult the tool help for more information on this. The selection type. Here we go, the selection type, new selection, add to the current selection. This is actually the dialog help. The Python help would be better in this circumstance. So there you go. So consult the help. What we need instead is subset selection. Okay, so just want you to select a subset of those features. Right. So let's save that. Let's see how it performs now with subset selection instead. And with subset selection, we're getting 0, 0 and 0. We're getting no selection. So what subset selection does basically is it combines any existing selection when it executes the Arcpy statement. Okay. So I've adjusted my working code here to add some diagnostics in as to whether the query layer, which is the root line in this case, has got any selection on it. But also this logic here controls the actual selection type based on if each comparison layer, the AONB in this case, has got a selection on it. And if it has got a selection on it, it says subset, so basically combined selection. If it hasn't, it just goes with new, the default. So that caters for that. So there'll be 2 different code paths. If you've got a selection on it, it will go subset. So look at that. It's looked for features that are close to this line. Yeah, using the 3 already selected, and it has determined that neither meet the condition of being none of these 3 selected are close to the root line. Okay. If I change the selection to be one that's on it, the result will be 1. Okay, so it's selecting that one feature which is directly on the root line. And if I have no selection at all, it'll just go straight with new selection, but I'll select the same one based on the 100 meters anyway. Keep using selection counts as a bit naff, so let's adjust this script a bit more. I'm going to add a processing counter and wrap up each iteration into a try block. It's always good practice when you have loops to wrap up each iteration into a try block. You don't always have to raise in each iteration. You can make it just warn. It's up to you, but it's good practice whenever you have a loop to have each iteration in a try block. In this case, if anything goes wrong, the entire script blows up. And I'm going to tweak the search distance to 5,000 meters. And I've added this extra snippet in here, this extra snippet down the bottom. I'm going to investigate this toggle here. Hang on, let's select a feature. In fact, let's select a few. This toggle here, we're going to investigate this behavior now because this is quite important. It is a change that came in ArcGIS Pro 3, that toggle. So what we're saying here is if there is a selection for each layer after it's done the selection based on the root line, we're only using 1 in this example. If this feature is selected, add it to the map. So what it's doing is it's creating like an in-memory data set here. It's using copy features to pass that layer with the selection on it. Again, the default behavior we would expect is if it has got a selection set, it will only use selected features. It will ignore everything else. And then we're wrapping it as a feature layer and then adding it into the active map. Okay. Let's add an extra bit of diagnostics in here. And this is checking that the selection set, after it's done the operation, it's checking that the selection set matches the result of get count. I've got a wrapper method here, helper method, which basically wraps up get count because I can't be asked bothered, excuse me, to type get count, management.getCount.getOutput 0 every time. So I've wrapped it up there. Okay, let's save this and let's investigate the behavior of this troublesome little toggle here. So I've got 4 selected features, and I'm saying I want you to extract those which are of those selected ones. Select once a bit closer. The ones which are, and I've hard coded 5 kilometers into my tool now. Obviously, we'd never do that in actual production, but whatever. 5 kilometers hard coded in. And let's see if it makes sense, makes logical sense. And yes, it does. I've said only use selected, so it hasn't grabbed this big one here, which just goes straight across the line. But this one here, I've got my pink, my sort of lilac here, and that has met the condition. So that's honored selection. What happens though, if I keep the selection on it, but I'm saying I've got selected records, but I don't care. I want you to ignore them. Now, what I would think would happen in this circumstance is it will just grab everything in the data set I'm passing in. It will just output everything which is within 5 kilometers. So it might be this one, it's going to be that one, it would definitely be this one. Let's see how that behaves. So switching this toggle off. Unpredicted behavior. And I've got a warning here. That warning from this statement here, Arcpy is ignoring the selection set. The result of get selection set is not the same as get count. What's happened? What's gone wrong here? Well, this toggle, and it has been noticed by other people as well, it has caused 1 or 2 gripes because it ignores any definition query, any filter on a layer as well. The toggle ignores selection and it ignores any definition queries as well. So it's been producing some unpredicted behavior for other users, been causing a bit of confusion. And what's happened is the first Arcpy call, select layer by location, has worked. How do I know it's worked? Because I've got the 2 records selected, the ones I would expect. This polygon and this polygon. But when you've got this toggle deactivated, it seems that Arcpy internally is ignoring every single subsequent call on that layer. So that's the first call. That's worked, selected 2 features. Thanks. The next call, get count, it's returning 34 records when I've got a selection set of 2. The behavior persists on that layer object with every single subsequent call within your script. That will cause issues in legacy scripts, no doubt, because people are so used to this behavior of when you've got a selection set and you run it into an Arcpy method, it honors the selection set. It ignores everything not selected. This toggle completely overrides that, and it's whatever the selection, if there's a definition query, anything, and subsequent calls to Arcpy. This is where the error has occurred. Every subsequent call to Arcpy with that layer passed in. Remember, this will have been noticed as a type of layer here. So it's just passed directly in and directly down, and it continues to exhibit the same behavior. And when we get to Arcpy copy features, it's like, yeah, you've got 2 selected, great, but you've got that toggled off on me, so you can have everything. And we don't get what we expect. We expect AOMB close to the root line, but we get everything. So this is a bit of a pickle, because of the toggle you can no longer assume that a layer passed into a GP tool as a parameter will honor selection. And yeah, as I say, it's caused a little bit of consternation for 1 or 2 people. How could we get around this? Well, we could use select analysis. That's one way of getting around it, but that would need us to be using a SQL query. So if we use select analysis, We could use that to extract features to help us get around this behavior, or the best way I can think of, which I'll come on to next, is just to rewrap. When the layers come in as layers, just rewrap them, and that will break this this unwanted behavior. So I'll come on to that next. Actually, let's briefly cover, try and get around this issue using the select tool from the analysis toolset. So making further adjustments to the script, then going to start with a helper method, which gets you the object ID of a data set. I'm going to add in some code here to replace this copy features and make feature layer with using analysis select instead. So let's comment those out. Whoops. Okay. Let's save this. See if this works. So what we're going to do here is we're going to just build a comma separated list of the selected object IDs. So in that previous example, there was 2 selected. And then this forms that into a SQL query. Okay, and it'll print out that query on screen to explain it better. And then it performs arcpy.analysis.select with the layer passed in, and this will have the ignore flag on it, if you like, that I've just discussed there. And then we're asking it to push it to the same place in temp, but we're using this where clause. And then it wraps that as a feature layer, and then it adds that to the map. So let's see if I go back to my history, take that flag off. Let's see if I get some better behavior now. See if it's honoring, if it's making a bit more sense. Okay, so that's better. Using analysis select, we can see here that we're getting expected results. We're getting the 2 polygons which are within 5 kilometers of the route line. So that's a bit better. But as I say, using in statements and stuff in a script, well, there are limitations to that, as I've just discussed. So let's have a look at rewrapping it first. So could you keep that query that we've built there? If I have a look at the tool diagnostics, there we go. So the query that it built was object ID in and then 10 and 12 based on the selection set. This next approach, we're still using the in statement, the where clause, but we're going to use make feature layer, and filtering it. We're not going to use analysis select, so we're just going to use make feature layer, passing in that original layer, and we're rewrapping it. So we're passing in a layer to make feature layer with that where clause on it. Let's see if that stops it from misbehaving with that flag ticked off. So let's run that again. And yeah, we're getting the desired result again. But we're still using a SQL in, which, as I've said, can have vulnerabilities, long in statements, performance issues. Why not just rewrap the layer and use set selection set? So tweak the code again, no longer using SQL query, and we say, and we get down here, we want a temporary path to a temporary data set. We just use Arcpy management make feature layer to just literally wrap it with no extra definition query or anything clever on it, just as the same name but with rewrap on the end. So we just pass the layer into make feature layer, and that gets rid of this behavior. We add it to the cleanup because we created a layer in our script, and then we set the selection set, and we just basically set it based on the selection set on the previous layer. So when we ran this before, it was selecting 2 records, whether this flag was on or not. It was the actual selection was working, but it was when we came to copy the output it was going wrong. So we pull it down here, we just rewrap it, set the selection set based on what it ought to be, and then we can use copy features without it going wrong. So I think rewrapping layers is the best way to get around this issue. So let's save and try that. Okay, so it has said, oh, warning, they don't quite match, but in rewrapping it, we're not needing to use a SQL in. Just by rewrapping and using set selection set, we're not needing to use a SQL in statement and the vulnerabilities or the potential performance issues of that, and we're getting the desired outcome. I think that is enough waffling on about this for now, and that brings me to the end of session 2. So in summary, well, you can use arcpy.gp.addMessage, add warning, add error to make information, warning, or error messages appear in the tool message or output history in ArcGIS Pro. And if we actually just go back and have a look, let's have a look-see, because I think I glossed over it earlier on. In my helper method here, we can see I'm using the same level flags, and I'm choosing Arcpy GP add message, add warning, or add error. And there are a couple of examples of me using this in the code by passing in a message level of 2. You see that warning that we've been seeing about ignoring the selection. Passing in a level of 1 gives a warning, and then 2, an error. Okay, so Arcpy add GP, add warning, add error there. Let's go back to my slide. As I was saying, so you've got those messages there as discussed, how to get your messages into ArcGIS Pro in the diagnostics. I've also covered a lot of error handling. And yeah, you want to combine using try and accept blocks, and it's in the accept block where you use add warning and add error. Warning to inform, but to continue processing, an error to make your script raise or throw or bomb or blow up, however you want to describe a script crashing. You can use raise to raise the exception up the call stack. You can use Arcpy get parameter or get parameters text to pass user input into script tools. And note that Arcpy can behave differently depending on which of the get parameter methods you use, and it's important to determine what suits your scenario best. And at times this can be counterintuitive. For instance, passing layer object versus layer name as a string makes ArcGIS Pro behave differently in terms of how it actually treats the layer. For simplicity, you could use get parameter as text and just use feature class types rather than layer and feature class. And as I've mentioned, that selection honoring flag, you need to be aware of that behavior and how that will affect layer objects you pass into your script. And I've covered wrapping up a script tool, basically adding the script to an Arc toolbox in ArcGIS Pro. Parameter ordering should always match the get parameter statements in the script, obviously. And you obviously link the script tool to your underlying Python script in the execution tab. And modern versions of ArcGIS Pro, yeah, just covered it and just discussed it again. They have an option to use selected records only, and this toggle has very significant effects on how layer objects behave when they are passed into the script tool as discussed. So there's more I wanted to cover into this session, but I've waffled on. And so still to do really is, well, the script tool it's still a bit naff, it's still half-baked. It needs extra input parameters. For instance, the distance is currently 5 kilometers hard-coded, and we've got a spatial method as intersect going into Arcpy there on select layer by location. It's hard-coded, that's not great. You want to expose as many parameters as possible to make your script tool versatile. It needs better flow control. An improved validation of inputs, I've done a little bit, but the secondary validation is still blank, and I haven't done the tool validator either, despite having mentioned it several times. Obviously, there's the validation of outputs and adding output parameters onto the script. I've made it add layers after it runs in code or during it running in code, but you really want to be doing that sort of stuff using output parameters instead. And then obviously a script tool or metadata and help. I haven't documented my work naughtily, but hey, isn't that how most people behave? Well, I do tend to like to document my work. So yeah, it's important to add metadata and help, etc. Okay, that's the end of this tech talk. I hope you're finding it useful. All the pitfalls and many trials and tribulations over years of working with Arcpy. I hope it helps people to learn Arcpy. If you want to see how I take this half-baked geoprocessing tool and turn it into the finished article, then watch the next video. Thank you for listening. Bye-bye.